folks, welcome back to physics. In this video, you're going to learn about how to add and subtract vectors. By the end of this video, you will be able to add and subtract vectors in both 1 dimension and 2 dimensions. So let's go ahead and get started. Let's talk about doing vectors in 2 dimensions. So in example 3, we have Michael. I'm going to go ahead and just start Michael here. And Michael is going to walk 3 meters north and 4 meters west. So we're going to figure out where he ends up. So Michael walks 3 meters north. I'm going to go ahead and draw that first. And I'm going to go ahead and also in my corner draw my compass. So at north, east, south, and west. So he's going to go 3 meters north and he's going to go 4 meters to the west, like so. And so we can go ahead and draw the resultant vector to show where he ends up. So we're going to start at our beginning of our first vector, draw a line straight to the end of our second vector, and that is going to be the resultant vector of Michael's motion. So we can figure out the length of that vector by using our Pythagorean theorem. So we've got 3 meters north, we've got 4 meters to the west, and this side here, our resultant vector is of course going to be our hypotenuse. And so what we can do is we can say 3 squared plus 4 squared is equal to c squared. So what we'll get is we will get 9 plus 16 equals c squared, or c squared equals 25, giving me c equals 5 meters. So that is going to be the length of my vector. And I can stop here and I can say, okay, so Michael traveled 5 meters northwest. But that's really not super specific, right? So instead, what I'm going to do is I'm going to figure out how we can turn this northwest into an angle. And to do that, I'm going to go ahead and draw my unit circle, the four coordinate axes of my unit circle, right where I started. So we've got 0 degrees pointing to the right, we have 90 degrees pointing up, we have 180 degrees pointing to the left, and 370 degrees pointing down. Now, the other thing that I'm going to do is I'm going to go ahead and complete this square that I've drawn. So I can put my 3 meters north on the left side, and I can put my 4 meters to the west down instead of up. I can create a triangle now that fits into my coordinate axis, and we can actually figure out how many degrees away from 0 degrees I am. So we can figure out this angle, which I'm going to call theta. And the way I'm going to do that is by figuring out this little angle here, which I'm going to just call A for angle. And the way I can figure out A is by using my trigonometric identities. So remember, SO, CA, TOA, sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And we have our hypotenuse side, right? We know that our hypotenuse is 5 meters, but the two things that we also know are our two sides. And you're gonna usually want to use the two things you were given in the problem to figure out what your angle is. So what I'm going to do is I'm going to say the tangent of my angle, so tan of A, is equal to the opposite side over the adjacent side, so 3 over 4, or A is equal to the arctangent, tan to the negative 1, of 3/4. And here you're going to want to stick this in your calculator to give yourself your angle, or you can just leave it as is. After all, this is an angle, right? So we could say 5 meters at tan to the negative 1 of 3/4. Or you can stick it in your calculator and get A is equal to approximately 37 degrees. So we now know, so I'm not quite done, sadly, because I found A, I have not yet found the angle of my motion, right? So what I'm going to do next is this very last step, which is to subtract A, 37 degrees, from 180, because we know from our picture that theta plus A is equal to 180. So that gives me theta is equal to 180 minus 37, or 143 degrees. So, my final answer is going to be that Michael ends up 5 meters at 143 degrees away from where he started. So it's a little bit challenging to do these problems, so let's go ahead and do one more. So we have Pam now, who is going to walk 8 meters south, 4 meters north, and 3 meters east. We're going to figure out where Pam ends up. So let's go ahead and start. I'm going to have her walk 8 meters south. So 1, 2, 3, 4. So here is my 8-meter long arrow, my vector. Then she turns around and walks 4 meters north. So I'm going to put the head of my new vector by the tail of my old one, and I'm going to go 4 meters north and end up here. Finally, she's going to walk 3 meters east, so 3 meters to the right, and end up at this position. So drawing my resultant vector is not quite as scary as it sounds. Again, I'm going to start my vector where I started my first vector that I drew, that 8 meters south, and end it where I ended my last one, and just draw the shortest possible line from point A to point B that I can. And let me go ahead and, while I'm here, figure out the lengths of the two sides of my triangle. So I know that I've got 4 meters left here, and I could just actually count squares, and that I have 3 meters pointing to the east. Finally, I'm going to go ahead and draw my unit circle. I'm going to draw a little bigger, right where I started. So we have 0, 90, 180, and 270 degrees. And last but not least, I'm going to go ahead and mark off my angle. So again, I'm going to start at 0 degrees, go all the way around until I hit my vector, and that is going to be my angle theta. So now I'm ready to go ahead and figure out the length, the magnitude, that is, and the direction of my vector. So first of all, I'm going to start by finding the magnitude, because that is easier. So I'm going to use my Pythagorean Theorem, and I'm going to say a squared, so 4 squared, plus 3 squared is equal to the length of my vector, c squared. And when I do that math, I will get c is equal to 25 meters. Or sorry, excuse me guys, I forgot to take the square root. So c squared is 25 meters, c is 5 meters. So I know that Pam ends up 5 meters southeast of where she started, and I'm going to go ahead and figure out what angle she's at. And again, I'm going to want to redraw my triangle. So this side here is still 4 meters, and my top here is 3 meters. So I can figure out pretty easily this angle A here. And I'm going to do that using, again, tangent. So I know that the tangent of A is equal to the opposite side over the adjacent side. So it's going to equal 4 meters, which is my opposite side, over 3 meters, giving me that A is equal to the arctangent of 4/3. When I stick that in a calculator, I get that A is equal to 53 degrees. Of course, again, I can't just say that A is equal to 53 degrees. I need to figure out what theta is. I need to figure out how far away from 0 my vector is. And to do that, I am going to remind you that 0 degrees is the same as 360 degrees in our unit circle. And to figure out the rest of our unit circle, so what I have is 360 degrees minus A is going to give me theta. So 360 minus A equals theta. So that means theta is equal to 360 minus 53, or theta is equal to 307 degrees. So what I'll say is that Pam ends up 5 meters at 307 degrees away from where she started. So this is a bit of a long video, so let's go ahead and talk about takeaways. First of all, vectors are added head to tail. And secondly, when you are adding vectors in 2 dimensions, you'll need to use the Pythagorean Theorem and remember your trig. So Hopefully this was a good review of how to add vectors. Go ahead and see how you can do it. Give it a try. Best of luck. Happy solving!